Hello students, this is Miss Pooja Arun Matre, lecturer in Electronics and Telecommunication Department in Praveen Patil College of Diploma Engineering and Technology, Bhayandar East. Subject is Computer Networking and Data Communication. The subject code is 22634. Now we will learn about the practical number 8. The aim of the practical number 8 is locate the error bit in the given data stream by applying the different error detection methods. So the practical significance is error is a condition where the receiver information does not match with the sender's information. That means the receiver information will not be matched with the sender's information. That means the what data is sender saying to the receiver is not received as it is. So during the transmission, the digital signal suffers from the noise and that can introduce the error in the binary bits. So it's traveling from the sender to the receiver. That means a 0 bit may change to 1 or 1 bit may change to the 0. So to avoid this, the error detection codes are used which are additional data added to the given digital message to detect the any error and that has occurred during the transmission of the message. So now we will learn about how to detect the error in the message. The program outcomes for these practicals are discipline knowledge, experiments and practice, and individual teamwork. The competency of this practical is we will learn about the various methods to detect the errors. So this will help to students to do the error correction methods in the industry. So relevant course outcomes is analyze the error detection or the correction and the flow control of the data in the data network. So there are the various error correction detection methods, that is a parity check, two-dimensional parity check, checksum and cyclic redundancy check, that is CRC. So first we check what what is parity check. So parity bit is a number of ones were present in a code. Parity bit means number of ones were present in the code. So this parity is converted into two types, even parity and odd parity. When a user sends a message in a binary code, so that time check how many times one is repeated in that message. If the count of one is even, then it is called the even parity. If the count of ones is odd, then it is called the odd parity. Then two-dimensional parity check will be given when the parity bits are calculated for the each row, which is equivalent to the simple parity check bit. So parity check bits are also calculated for the columns and then both are sent to the data. So at the receiving time, these compare to the parity bits with the received data. And the third one is the checksum. So checksum is also an error detection scheme. So this time data is divided into k segments into the same number of bits, that is m number of bits. So when the sender sends a data to the sender, that time senders added the ones complement of the arithmetic into the sum and this sum is complemented to get the checksum. So checksum segment is sent along with the data segments at the receiver side and receiver receives the data with the original data plus the ones complement as the sum. If the both data is matched, that time only receiver received the packets, otherwise it reject the packet. And the fourth one is the CRC, that is cyclic redundancy check. So CRC is based on the binary division. So when it divides the data, that time he check the quotient of the number. If the quotient of the number is added to the original data and this packet is sent to the receiver. Receiver received the packet and again divide the packet. If the quotient and remainder is matched with the sender, then that time only packet is received, otherwise packet will be discarded. So block diagram of the parity check is given here. Sender sends the data that is 1000011. It computes the parity, that is sender and receiver decided to send the data in a even parity. But in the original data there are only three number of ones, that is odd parity. So if they are decided to keep a even parity, so sender add a additional one to the original data. So it maintains the even parity and it transmits the data through the transmission medium. At the receiver side, receiver check the data and compute the parity bits. If the parity is in the odd, so that time he reject the data. If the parity bits of the ones is a even parity, then he accept the data and sends a message to the sender that the successfully received. So for this we will see the program in Turbo C. The code of the program is given in the manual. So we will type all the code in the Turbo C software. Parity bit program. We have typed the program. So Parity bit electronics telecommunication department program in using the C program, that is Turbo C software. So here we are using the Boolean values. For that we included the standard header file and defined the Boolean integer. So Boolean will calculate the parity bits, which is unsigned integer. So first we will set it 0 and it will count till the n. If the parity is not equal to the given parity, that time n will be minus and return the parity bits. So unsigned bit is n. So 7 number is become 0 1 1 1. So number of ones are odd. So we will check the output will be given is odd parity or even parity. For that get parity will check with the number and we will see the answer. So after the typing of program, we will compile the program to check whether there is an error or not. So here is a no error. Then we will run the program using the Control F9 key. So parity of number 7 is odd and this is the right answer. So after the parity bit, second one is a checksum. So checksum is another error detection method. In the checksum, we will take the out. We will divide the data into number of parts. So here is the 16-bit data, that is 100111001 and 1110010. So we are divided the data into 8 bits and the K section is the K parts, that is a 4 part and each part contain 8 bits. So after the when we are divide the data into K parts, that is the 4 parts, we will add the 4 parts together. So here is the addition of the bit. After the addition of the bit, we will get the answer and these answer become the checksum bit. So this checksum bit is added together with the original data. So at the receiver side, receiver also take the ones complement. Ones complement means the 1 is replaced with the 0 and 0 is replaced with the 1. And this checksum bit is added to the original data and it is forwarded to the receiver through the transmission medium. So after the transmission, receiver received the data with the checksum bit. So it will take to the ones complement and get the original data. If the both checksum bits are at the receiver side, the checksum bit is 0. That time he will concluded that it accept the data, otherwise it reject the data. So for this equation, we will see the program in Turbo C software. The program for the checksum is given in the manual. So for this, we have to add the three header files, that is standard input output, console input output, and the math. Math is used for the division, multiplication, addition and subtraction arithmetic operations. So at the sender sides, sender declare the array, that is B, with 10 size and the K for the partition of the bits, and the checksum variable, and the sum is equals to 0. So at the sender sides, the sum of the K parts will be added together and the result is stored in a checksum build. So sender checksum is checked. At the receiver side, it will get the data with the checksum bit. So at the receiver side, the sum is compared with the array and the sum is added to the checksum bit to the ones complement. When the both data is matched, then the data is accepted. So if there is a data is not matched, the no error in the transmission will be displayed on the screen. So after writing the same program which is given in the manual, we compile the program. There is a no error and we run the program. So here is the output of the program. Then the third and the last is the CRC, that is cyclic redundancy check. For this we want a divisor and dividend. So this is the division method using the CRC, and we will took the binary code division. For this the program is given in the manual. We will run the program in Turbo C software and see the output. The code is written as it is, which are given in the manual. So checksum build divide the binary code. Is the binary code divided the division, we will check the remainder and the quotient, and the remainder and quotient is given. Now we will compile the program. There is a no error. After compilation, we will run the program. So the output of the program is given here. The quotient and remainder is given over here. So here the practical number 8 is completed. Thank you.